In this video, we're going to talk about implication in terms of logic propositions, all right, or compound proposition. And implication actually comes up in quite a few different ways in the English language. So the book, they took a moment and they listed a bunch. So it could be the form if then. By the way, this is the form we tend to stick with the most in this class. It's just easier to see. If something is true, then something follows. Okay, that's kind of the way we look at it. But it could be worded if P, comma Q. They don't have to use the word then. They could use the word unless. They could put it backwards. Q happens if P, Q whenever P, Q follows from P implies Q, P only if Q, and so forth. Okay, you can read all of these yourself, but as you see, there are lots of ways of using implication. This is why we're going to take a second to kind of talk about it separately from the other compound propositions. Okay. All right, so here's how we look at it. This is the symbol we use, this little arrow. That arrow means implication, and they call it a conditional statement. That's the other phrase they like to use, conditional statement or conditional. They'll even just say that, okay? And it means if P, then Q. All right, so here's how the truth table works. So true, true, false, false, true, false, true, false. Okay, so if we start with something true and we say it gives us something true, that's good. If we start with something true and it say it gives us something false, that's bad. If we start with something false, but we get something true, that's not a problem. And we're going to talk about why. And if we start with something false and get something false, that's actually a good argument. So let me give you some examples here. So using the phrases that we were using before, if P is I am at home, Q is it is raining, then P implies Q denotes if I am at home, then it is raining. Okay, so that's how we write that statement. Now, real quick, they do have some different phrases to refer to P and Q. One phrase is hypothesis, antecedent, premise. For Q, it's often called the conclusion or the consequence. But as you could see, there's so many different referrals to this. And this particular conditional proposition gets used a lot in mathematics, even beyond computer science. It's used in a lot of mathematics, and in even it has implications into English. Okay. Okay, so let me explain why the truth table is kind of set up this way. All right. Kind of makes sense when you think of and versus or. And means both of them needs to be true for it to make sense. Or one of them might be true. That's okay. All right. But then, if then is very specific. We have one case where it's a problem. So here, let's look at this example. Suppose your basketball coach made the following statement. If you play well in practice, then you start in tomorrow's game. So there's the if then statement. So we're going to look at different versions of true versus false. Okay. So in part A, you play well in the game. That means that the first part of this was true. And then the coach made good. You started the game the next day. Okay. So this ends up being a positive or a valid statement based on what your coach told you. So that one's good. Coach treated you well. Okay, the second one, you played well in practice, but you didn't start the game. Okay, now that's a problem. The coach lied. In this case, you're being treated unfairly. All right, the coach lied. Okay, now the next one, you didn't play well in practice, but the coach went ahead and started you. Well, that's actually not a bad thing. The coach was like, nice. They were merciful. They decided to let you start. So in this case, you don't feel like you treated unfairly. You kind of feel like you were given a break, right? You didn't do so hot in practice, but the coach decided that was okay. It was still all right for you to start. Let's say you didn't play well in practice, but you didn't start the game. That's fine because the coach didn't lie in that case either. That's exactly what the coach said would happen, right? You don't play well, you don't get to start. So there's only one case where it's a problem, and that's the case where it makes the coach be a liar. So even though in part C, it seems like it's a problem, or even part D, when they're both false, it isn't. It's only in the case where you start with something true and you result in something false that it is a problem. Okay. Okay. Now we create some new conditional statements from the if then format. The first is called the converse. Okay. The converse reverses the premise and conclusion. So it switches the P and the Q. That's the converse. The contrapositive switches them and makes them negatives. All right. The last one here, the inverse doesn't switch them, but makes them negatives. Okay. So we're going to go ahead and look at converse, inverse, and contrapositives for this statement. Okay. And see how that kind of works. Let's start with the converse. I notice, oops, gotta select the pen. I noticed that they switched the order of the inverse and contrapositive. That's fine. Who cares? Converse. Okay. So our if then statement is if it is raining, it's raining is sufficient condition for my not going to town. Okay, so I see the way that's worded, and that's not quite an if then statement. Okay, so I'm going to make it an if then statement. Let me start with that. And here I'm going to do it in blue. So what we're saying is if it's raining, then I'm not going to town. Clearly, they don't live in Oregon, right? Then you're never going to go anywhere. All right. So there's the if then statement. So now let's start with converse. So the converse switches them. So the converse says, if I'm not going to town, then it is raining. Now, looking at that statement, that doesn't necessarily have to be the case, right? It could possibly be that maybe there's a different reason you didn't go to town. Maybe you don't feel good. All right. But that's what the converse says. Okay. So there's converse. All right. So now let's do inverse. The inverse of the statement negates them. So if it's not raining, or you could say if it isn't, if it's not raining, then I'm going to town. Notice how I dropped the not for the second part, right? That's what the negation of not going to town would be. It would be going to town. Okay, contrapositive. So contrapositive swaps them and negates them. So if I'm going to town, then it is not raining. Now that actually really does make sense based with our first statement, because that seems clearer. Since you're saying that rain is going to prevent you from going into town, but you're going into town, then it's probably a good thing to say that it's not raining. Like that makes sense based on the very first statement in blue. And I believe the next example actually wants us to compare that. Show a truth table that the conditional is equivalent to the contrapositive. So conditional is P implies Q. That's the conditional. The contrapositive is not Q implies not P. All right. So if I want to figure that out, I need to compare these two. So first thing I'm going to do, I need to find not P, not Q. I need to find P implies Q. And then I need to find not Q implies not P. So I'm ending with the two statements I'd like to look at. These are the two I'd like to compare, right? Those two here. And I need to know what not P and not Q look like in order to do the last one. Okay, so true, true, false, false, true, false, true, false. Okay, before I do the not P, not Q, I'm actually going to go ahead and skip to this column because I can do that. So P implies Q, or if P, then Q. So whenever the conclusion is false, when we start with true, that's the only problem. False implies true is okay, and false implies false is okay. And again, you could go look up at the truth table above, right, to look at that. Okay, now I'm going to move on to the next two. So not P is false, false, true, true. Not Q is false, true, false, true. Okay, but now I'm going to look at them in reverse for the implication. So I'm looking at this implying this. Okay, so false implies false. That's not a problem. True implies false. That's a problem. False implies true, not a problem. True implies true, not a problem. Okay, so just be aware, I'm kind of doing this last column backwards, okay, based on the if-then statement. Now, here's what I'm noticing. These two columns, their truth tables completely match. So that means they're what we call equivalent. So when the truth tables match, that means that they are equivalent. They are the same statement written a little bit differently. All right, and we'll save the more compound propositions for another video.